Hi guys, today we're going to be looking at the Chapter 7 test review. We're going to start with this first page, which is all about the multiple choice section of this test. Okay, so let's go ahead and begin with number 1. So it says, a large pet store that specializes in tropical fish has several thousand guppies. The store claims that the lengths of these guppies are approximately normally distributed, with a mean of 5 centimeters and a standard deviation of 0.5 centimeters. You come to the store to buy 10 randomly selected guppies and find that the mean length of your 10 guppies is only 4.8 centimeters. Identify the population, parameter, sample, and statistic. That is all we are doing in this problem, is we are just trying to identify what those 4 things are. So over here, I'm going to write population, parameter, sample, and statistic. So if we go right down the line, we're going to start with population. So with our population, we're trying to figure out what is the key thing that they're talking about. What is the big group? What's the big picture? And that would be the several thousand guppies at the pet store. So for population, I'm going to write the several thousand guppies at pet store. Okay, now for that parameter, that's trying to figure out, or that's trying to determine what is the main thing that we're looking for. What are they curious about? What do they want to know? And in this case, they want to know the lengths of the guppies. So the parameter is going to be the true mean length of all the guppies. True mean length of guppies. Okay. And let's move on to sample. So sample is, who did they ask? What did they collect? Where are they getting their sampling distribution? What are they specifically looking at? And they are specifically looking at 10 randomly selected guppies. So 10 random guppies from the store. Okay. And for the statistic, we're trying to figure out, well, what did they find out about this sample? So in that sample, they found 4.8. So we're going to say that our statistic is the average length of the 10 guppies was 4.8 centimeters. And that is all you have to do for that. You're just identifying those 4 things. Okay, number 2 was a little confusing because in number 2, it said about 10% of people in the United States have type B blood. Which of the following is a reasonable sample size to make the distribution approximately normal? So keywords there are approximately normal. So what we have to do is we have to use a conditions check to figure out if it is approximately normal. But then the question becomes, do we use the large counts condition for proportions, or do we use the central limit theorem for mean? So we're going to look at the other piece of information that it gives us, and it says 10%. So we said way back when that a percent, a proportion, and a ratio, all of those are going to follow the large counts condition. So large counts condition. And there are 2 pieces of really good information that we need from the large counts condition. In order for it to be normal, n times p has to be greater than or equal to 10. And n times 1 minus p must also be greater than or equal to 10. If both of these work, then it is said to be a good distribution. So for this problem, we're going to let p equal 0.10. Never, ever, ever use a whole number for a proportion because all proportions are less than 1. And the answer choices are going to be our sample size. So for this first one, it's saying that if a sample size of 90 and a proportion of 10%, will that be greater than or equal to 10? So we're going to go off to the side and we're going to do 90 times 0.10. Well, 90 times 0.10 is 9. And 9, unfortunately, is not greater than or equal to 10. So because that is not true, 90 is not a good sample size. So then we're going to look at 80. Is 80 a good sample size? So n times p. 80 times 0.10 is 8. We want to know, is 8 greater than or equal to 0? Or sorry, greater than or equal to 10? And the answer is no, it is not. So 80 is not good. So then we're going to look at 120. Do 120 times 0.10. And whenever you multiply that, you actually get 12. And 12 is greater than or equal to 10. So that's the first condition met. But we also have to check the second one for the large counts condition. So I'm going to do 120 times 1 minus 0.10. And that will give me 108. And 108 is greater than or equal to 10. So that's good. Now, look how it said choose all that apply. That means there might be another answer. So we're going to check the next one. 100 times 0.10, well, that's 10. And then a lot of people get confused with this because it's 10 greater than or equal to 10, and it's equal to 10, so the condition is met. Then we're going to check the other one. We're going to do 100 times 1 minus 0.10, and we get 90, which is also greater than or equal to 10. So both 120 and 100 would be good sample sizes. Number 3 is just a general, you need to know this, okay? If we use a sample statistic to estimate a population parameter, it is said to be unbiased. Okay, this kind of gives us the ability to use sample statistics to estimate the population parameter. It's the entire purpose of statistics, is to be able to make assumptions about the population. And we can't really make assumptions about the population if it's biased. So if we are going to use a sample statistic to estimate that population parameter, we're going to say that it's unbiased. Okay, number 4 says if 95% of students like dogs and we take a sample of 52 students, what is the mean and standard deviation? So this comes from 7.3. We're going to use one of the formulas for mean or standard deviation, for means or proportions. And we have to figure out, is this a mean question or is this a proportion question, to figure out which of those standard deviation formulas are we going to use? Because remember, there are 2 different formulas. Now, the dead giveaway as to which formula we're going to use comes from this 95%. Okay, so the 95% tells me that my average that I'm looking for is going to be the mu of p hat. It's the mean of the sample proportion, and that's going to be equal to the population parameter. Now then we have to find the standard deviation of that sample. We have to scale it down to match the sample. So we're going to use the formula, the square root of p times 1 minus p divided by n. And so in this case, p is 0.95. So we're going to do 0.95 times 1 minus 0.95 divided by the sample size, which is 52. Okay, and then if you were to do that, I believe you get 0.0302. Make sure that you're typing this in correctly, because if you type this in incorrectly, it will be wrong. Another thing that people are going to mess up on a lot in this problem is a lot of people aren't going to convert that percentage into a decimal. If you do not convert that percent into a decimal, this will show up as undefined in the calculator. And it'll give you some reasons, such as you cannot find the square root of a negative number because that would be an imaginary number. And we're not doing imaginaries in statistics. So in order to prevent that, let's make sure that we always convert our percentages to decimals. Otherwise, nothing's going to work. All right, number 5. Suppose the number of minutes spent talking on the phone per day in 2009 by high school students follows a left-skewed distribution with a mean of 45 and a standard deviation of 5. What will the distribution of the graph be if we take a sample of 20 students. So for this, we're going to look and see, is this a mean or is this a standard deviation? And it says right here, it's a mean of 45. So that tells us that this question is an average. So for averages, we're going to look at the central limit theorem. This is from your 7.5 notes. So the central limit theorem states that if the sample size is greater than 30, greater than or equal to 30, then the distribution will be normal. No matter what, the distribution is going to be normal. However, if the sample size is less than 30, then it takes the same shape as the population. So for this one, it says that the sample size is 20. So we're going to look, is 20 greater than or equal to 30? No. So because of that, it's going to take the same shape as the population, and the population shape is left skewed. So the shape for this is going to be left skewed. Or you could put skewed left. Letter B says, what will the distribution be if the sample was 30? So is 30 greater than or equal to 30? Yes. So because the sample size is greater than or equal to 30, we're going to say that this is normal by the central limit theorem. Okay, part C says, what will the distribution be if we take 15 samples, or a sample size of 15? So is 15 greater than or equal to 30? No. And because it is not, it's going to take the same shape as the population. So we're going to say that it is skewed left. Okay. Now that bottom part says, what are the different formulas for? This is kind of for you to look at, so that way you can see what all types of formulas we have to offer in chapter 7. And I went ahead and I just wrote them, a couple of them. So if you want to look over them, you can. So for checking for normal distributions, we have the large counts condition and the central limit theorem. And these are the two formulas that we use to determine if it's a normal distribution. We also talked about the different standard deviations. So for a proportion, we use this one, and a standard deviation, we use this one. We also talked about Z, how it is equal to X minus the mean divided by the sample standard deviation. So make sure that you are using that sample standard deviation for these. In our next video, we are going to look at the